So hi and hello there, welcome to the new video of the course, and in this particular video we are going to see the first mini project of the course, that is automatic brightness controller. So at the end of this particular video you will be in the situation to understand how the brightness of your smartphone is getting controlled with respect to the external light source. So what I mean to say is, if you are operating your smartphone in presence of the sunlight, the brightness of your smartphone increases. On contrary, if you are operating your smartphone in home conditions or in your home conditions, so the brightness level decreases. Okay, so I hope that you might have experienced these particular things. Okay, so now what we'll do, we'll move to the block diagram of this particular project. As you can see, this is the block diagram of our project, and the block diagram consists of three major, or the three important components, that is one sensor, one controlling system, and one output. Okay, so the sensor that we are going to use for this particular project, that is LDR. We are going to see what exactly this LDR is. Then the controlling system is basically made up of a BJT, a single BJT transistor, or the bipolar junction transistor. And basically what we are doing, we are using BJT as a switch. Okay, and depending upon the state of the BJT, either it is in on or it is in off condition, the output is going to be displayed with the help of this particular light emitting diode or LEDs. Okay, so now that we had understood the block diagram of the project, so we'll focus on the sensor part, that is LDR sensor. So basically LDR sensor is an optical sensor. What it does, it converts light energy into an electrical energy. Okay, so this is how the LDR sensor looks like. Okay, this is how the LDR sensors look like. And the full form of the LDR sensor is light dependent resistor. So that means what? Just by looking at this particular full form, what we can conclude is this particular resistor is the function of light. Okay, is the function of light, or in general function of photons. Why? Because light is what? Basically package of photons. Okay, I hope you know this particular thing. Okay, and in this particular in this particular video, we are not going to derive, or we are not going to look upon any formula related to this particular sensor. We will see this particular thing in great depth if we are when we are learning the sensors part. Okay, so lots of things comes under the sensor, like chemical sensors, a mechanical sensor like pressure sensor and all, and one part that is optical sensor, and this particular LDR sensor falls under the category of optical sensor. Okay, so at that time we will see each and everything about this particular sensor in great depth. But now what we are going to do, we are just going to understand the working part. Okay, which act as an application for our mini project. Okay, so that's what we are going to see. So now what I'm going to do over here, I will just read these two particular points and then we will see this particular point. Okay, so basically these two particular points act as a basis, or act as a foundation for the working of this particular LDR sensor. Okay, so let me just read this particular point. If a light from any external source is incident on LDR sensor, its resistance decreases. Okay, and the fourth point is, the resistance of the LDR sensor is in mega ohms and it decreases to few ohms when any light ray is incident on it. Okay, sorry. So let's suppose we are assuming this as an external light source, maybe as a sun. Okay, and we all know sun emits certain light rays, which we call a, or which we term as sunlight. Okay, so let's suppose sun is emitting certain rays of light, that is sunlight. It is emitting sunlight, obviously. And then what we are going to, we are blocking this particular sunlight with the help of certain opaque material. That means what? It is not allowing any sun rays or any sunlight to penetrate or to pass through it. Okay, so that means what? There won't be any sunlight incident on this particular LDR sensor. Okay, so we will read the fourth point again. The resistance of the LDR sensor is in mega ohms and it decreases only if, or it decreases to few ohms only if there is any ray of light incident to it. Okay, so that means what? Since there isn't any light ray or external source of light that is incident on this particular LDR sensor, right? So the resistance of the LDR sensor would be in few mega ohms. So the resistance of the LDR sensor would be in few mega ohms. Great. So that means what? It will act as if it is open circuited. So that means what? It will act as if it is open circuited. So this will act as if it is open circuited. Open circuit, right? Or it will provide high resistance. What we can write, it provides high resistance. As you can see, it is in mega ohms, so it act as if it provides high resistance. Great. So this is what we had understood till now. Okay, and we also know that we also know that by Ohm's law V is equals to IR, and we also know that I is equals to V by R, right? So now see over here, your resistor, the value of this particular resistance is high. Okay, so your current should decrease, or it should be negligible. So that means what, your current is inversely proportional to the resistor, right? Resistance, that means what, if your resistance or if the value of resistor is high, the value of the current would be low. So that means what, let me write over here, this is what we had concluded. Just a second, let me just write over here, the value of the current would be almost negligible. So your current would be almost negligible, or it would be 0 ampere or milliampere. Okay, we will write milliampere. Okay, so that you won't get any doubt in your mind. So let me just draw one line over here. Just a second. Yeah, and this is what we had concluded. That means what, just a second. Yeah, so but I will take different color. Yeah, so this is what we had concluded. So when any sunlight is not incident on this particular LDR sensor, so the resistance of this particular LDR sensor, it is in it is in mega ohm. So the resistance of the LDR sensor, RLDR, I will write RLDR, it is maximum. Okay, it is maximum, and your I, or the current flowing through this particular LDR sensor, I, it would be almost equivalent to 0 milliampere. Okay, let me erase this first. Okay, so your I would be almost equivalent to 0. So this is what we had concluded till now. Okay, so now we will move to the second case, where what we are doing, we are just removing this particular opaque material. Okay, and what we are doing over here, we are just allowing the sunlight to be incident on this particular LDR sensor. Okay, so now the sunlight is incident on this particular LDR sensor. Okay, so let me write over here, this is your sun, and it is emitting certain set of photons, that is known as sunlight in general, in layman's term. Okay, or in layman's language, it is a sunlight. Okay, and now we'll move to this particular point over here. The resistance of the LDR sensor is in mega ohms, and it decreases to few ohms when any light ray is incident on it. Okay, so that means, as you can see over here, this set of sunlight, or this set of light is incident on the LDR sensor, right? So now the resistance of the LDR is going to be dropped to certain ohms. So let's suppose if it is 100 ohms. Okay, so now what does that mean? That means your resistor, or the resistance of the resistor, decreases. Okay, the value of the resistance got decreased. Okay, so let me just show over here how exactly it will look like. So just a second. Okay, and this is how it is going to look like. So it will act as if it is short circuited. So it will act as if it is short circuit. That means what, now the current will be able to flow through this particular resistor. Okay, so I hope you are getting my point. So it will act as if it provides less resistance or negligible resistance, less resistance. Okay, and with this particular equation, that is I is equivalent to V by R. So over here, your value of R is decreasing, right? If your value of R is going to decrease, so that means what, the value of current is going to increase. So over here, the value of current I would be maximum as compared to the previous case. It was almost negligible in the previous case. Over here, it would be more as compared to the previous case. So I will prefer writing it as max. Okay, so that means what, the value of the current will increase. Okay, whenever any light is incident on this particular LDR sensor. Okay, great. So this is the conclusion. So RLDR decreases, and the value of the current, it is almost maximum. Okay, as compared to the previous case. So this is the conclusion from my side. Okay, just by understanding this particular concept. Okay, so we need to focus only these 4 points as of now. Okay, we did not worry about this particular working of the sensors in depth, like understanding formulas and deriving the formulas and all. And as you can see over here, this is how the resistance will decrease whenever any whenever a ray of light is incident on that particular LDR sensor. Okay, if the intensity of the light, which is just a second, if the intensity of the light which is falling on this particular LDR sensor, it is more. Okay, so if the intensity of the light rays or the light is more, uh, so as you can see, the resistance of this particular LDR sensor, it is decaying exponentially. This is how it is going to decay exponentially. Okay, so I hope you understood this particular concept of the LDR sensor and obviously the working part of the LDR sensor. And now with this particular basic understanding, we are going to understand what we are going to understand this particular project, that is automatic brightness controller. Okay, so let me move further. So now what we are going to do, we are going to understand certain things over here and few of the things while understanding the circuit. So as you can see over here, this is the torch. Okay, and when we are going to switch on the torch, so obviously it is going to emit certain ray of light, okay, which would be incident on this particular sensor, and then the the resistance of this particular LDR sensor is going to decrease. So we will understand this particular part while understanding the circuits. Okay, like while understanding the working of this particular circuit. This is your BJT transistor, and I will explain this particular part while understanding or while explaining this particular circuit. Okay, and I had connected 500 ohms over here. Why? Because sorry, to assure that there won't be any maximum current flow through this particular LED. Okay, why? Because if maximum amount of current flows through this particular LED, so there would be maximum drop across this particular LED. And let's suppose if the voltage drop exceeds above 5 volts or above 4.5 volts, okay, so this particular LED will explode. Okay, so to overcome this particular issue, what I had done, I had connected this 500 ohms over here. So what is going to happen, there would be certain voltage drop across this 500 ohms, and there would be certain voltage drop. Obviously it should be less than 4 volts or 4.5 volts, so that this LED would be working in fine condition. Okay, if it exceeds more than 4.5 or 5 volts, it is going to explode. Okay, or it is going to burn. And this is the voltage source or the DC voltage which we had connected over here. Okay, to which act as a supply voltage to this particular circuit. Okay, and we will see what voltage should we take or what voltage should we consider to connect to this particular circuit. Okay, in the while explaining the circuit. So let me move further. Alright, so as you can see over here, the torch is in off condition. So as the torch is off, so obviously none of the light is incident on this particular LDR sensor. So that means we are talking about this particular case. So as you can see, as our torch over here, it was sun. Okay, so as our torch is off, so none of the light is incident on this particular sensor or incident on this particular LDR sensor. So it will act as an open circuit or it will provide high resistance. Okay, so let me move further. Okay, so that means what, it provides high resistance, as you can see over here. So that means what, there won't be any current flowing in this particular direction. So the current I1 flowing in this particular direction would be 0. Current I1 flowing in this particular direction would be 0. I1, let's suppose the current flowing through this particular loop or through this particular branch, it is I1 and it is 0 milliampere or 0 ampere in general, right? And while studying the voltage divider bias, we had seen that again I will draw over here. So let's suppose this is your current I1, this is your current IB, and this is your current I2 flowing through 50k ohm of resistor, right? So this is your current I1, which is 0. Why 0? Because this LDR, it is acting as an open circuit, and since I1 is 0, we all know that I1 is equivalent to IB plus I2, right? So this is your I2 and this is your current IB. So that means what, if I1 is 0, then obviously your IB is also going to be 0, or there won't be any current flowing in BJT. Okay, so let me just write over here. So that means what, let me just decrease the width of this particular line. Yeah, so the current IB, which is flowing in the base terminal of the transistor, so it would be 0. So your IB, since your I1 is 0, therefore your IB would also be 0 microampere. Okay, so that means what? That means the voltage drop across this particular base emitter terminal, that would be less than 0.7 volts. So your voltage drop VBE, that is going to be less than 0.7 volts. 0.7 volts. Okay, so that means what? Your transistor is going to operate in the cutoff region. I hope you are able to understand this particular point, my dear student. So let me write over here. So what we can see over here is, since the current I1 is 0 milliampere. Okay, why? Because your LDR acts as an open circuit, or it provides high resistance. Okay, which we had written previously. Okay, so I'm not writing over here. And since your I1 is 0, so therefore your IB, or the base current, is equivalent to 0 microampere. And since your base current is 0, so that means what? Your IC, therefore we all know that IC, or the output current IC, is beta times of IB, right? Since your base current is 0, so therefore your IC would be 0 milliampere. Okay, so therefore your IC is 0 milliampere. Okay, and we all know that if base current and collector current is 0, that means your transistor is operating in the cutoff region, or it acts as an open switch. So as you can see over here, this is how your transistor is going to look like. Why? Because there is very minimum drop across the base emitter terminal, which is less than 0.7 volts, obviously. So there won't be any current flowing through this particular BJT transistor, right? So what does that means? Therefore, the transistor, just a second, when I will write over here, when the torch is off, the torch is in off condition, BJT acts as an open switch. BJT acts as an open switch, right? BJT acts as an open switch. Okay, and therefore LED will be off. LED will be off. Okay, so let me just draw over here the output characteristic. So this is your VCE, this is your IC, right? And let's suppose this is the load line, something like this. I'm drawing it roughly. Let's suppose this is your load line, and since your IC is 0, that means the Q point would be somewhere over here. So if your IC is 0 and your IB is almost equivalent to 0, but it is not 0, as I told you in the previous case as well. Okay, so just a second, I'll draw it roughly. So it would be something like this, right? So this is your Q point, right? So basically your BJT is operating in the cutoff mode. BJT is operating in cutoff mode. Extremely sorry, I just forgot to write the parameters over here. So this is the graph between VC. I hope you know this particular thing. VC, that is output voltage, and the output current IC, right? So basically your BJT is operating in the cutoff mode, or in the cutoff region, and that's why your LED is off. So that means what? In your, try to understand, or try to relate it with your home condition. That means what? If you are operating your smartphone in your home, okay, in your home condition, so what is going to happen? Obviously, light rays falling on that particular sensor which is present on your smartphone. This we'll see like where exactly that particular sensor is located in our smartphone in the after a certain time. Okay, so just give me few more minutes to understand that as well. So in your, let's suppose if you are playing PUBG or something like that, okay, if you are operating your phone in your home conditions, okay, so at that particular time minimum amount of light rays incident on this particular LDR sensor, so your brightness of the smartphone is very less. Okay, it is very less. Okay, so try to relate that particular condition with this particular condition. That means what? If your torch is off, so the current I1 passing through this particular LDR sensor, it would be 0. Why? Because this LDR would be operating as if it is open circuited, right? And since I1 is 0, so with this particular relation, your IB and I2, they are going to be 0, right? So if IB is 0, that means what? The voltage drop, the base to emitter voltage drop, that is VBE, it is less than 0.7 volts, right? And if it is less than 0.7 volts, so your BJT acts as an open switch, and since it acts as an open switch, so that means what? It is operating in the cutoff region, and if it is operating in the cutoff region, so therefore this LED will be off. Okay, so I hope you understood everything up till now. Great. So now what we'll do, we'll move to the next case. Okay, so let's suppose this is your torch and now it is in the on condition. So let's suppose the torch is on. Let me write over here, this torch is on. Okay, now let's suppose this torch is on, and as you can see, it is emitting certain ray of light, and this light is incident on this particular LDR sensor. So now what is going to happen? Again, we will take that particular current into account over here. So let's suppose this is the current I1, this is IB current, and this is I2. So let me write over here, this is current I1, this is current IB, and this is current I2. Great. And you all know that I1 is equivalent to IB plus I2. Great. So over here, as you can see, this particular LDR sensor will act as a closed circuit. That means what? It is going to provide resistance, but that would be in few ohms. That means what? Your I1 would be maximum. So your I1 in this particular case, it would be maximum, and since your I1 is maximum, therefore your IB would also be maximum. Right? Since your I1 is maximum, so your IB would also be maximum. So that means what? If your current IB flowing through this particular circuit, it is maximum. Let me just show over here. IB would be maximum, right? And this from here there will be I2 flowing in this particular circuit, right? So that means what? The voltage drop across this particular transistor, that would be greater than 0.7 volts. So let me show over here, this VBE would be greater than 0.7 volts. This VBE would be greater than 0.7. Just a second, what I will do, erase this particular thing so that whenever you will refer my PDF, you should see this particular thing properly. Just a second, let me erase it properly. Yeah, so over here the voltage drop across the base emitter terminal, it would be greater than 0.7 volts. Just a second, let me read it properly. So yeah, your VBE is greater than 0.7 volts. Okay, great. So now what is going to happen? If your IB is maximum, just a second, let me write over here, if your IB is maximum, right, if your IB is maximum, that means what? Therefore your IC, we all know that IC is beta times of IB. IC is beta times of IB. Okay, so that means what? Since your input current is maximum, therefore your output current would also be maximum, right? So I will write over here IB max and IC max, indicating that these two currents, they are maximum. This is your input current IB max, and as your input current is maximum, therefore your output current IC, that would also be maximum. Great. So I hope you understood up till here. Okay, so that means what? Let me move further. Just a second, let me see what all points I had written over here. Okay, just a second, I just forgot to write one more point over here. That is, over here your LDR is acting as a closed switch. So what I will do, I will write that point over here. Let me just move it down. Alright, so over here your LDR is acting as if it is in closed switch. Okay, so LDR acts as a closed switch. LDR acts as a closed switch. Great. LDR acts as a closed switch. Okay, so I hope you understood everything up till now. Okay, so now I will explain you that why I had connected this 50 kilo ohm of resistor over here. So see over here, just a second, there is current I1 flowing in this particular direction. Okay, just a second. So this is your current I1 flowing in this particular direction, and now let's suppose if this current is reaching at this particular node. So now it is getting divided into two parts, that is IB, and the second one, that is I2. So I2 will flow in this particular direction. But over here what we need to do is this. That means what we want that your IB, or the input current of the transistor, it should be greater than I2. Why? Because if IB is greater than I2, then obviously this LED will glow. That means what, we want to operate this particular transistor in the saturation region. Okay, and for that, if we increase this particular resistor, okay, if we are increasing the value of this particular resistor, or we are connecting high resistor over here, okay, that means what, your I2, if your R is increasing, your I is going to decrease, right? This is what we had seen. Okay, so that's why over here we are connecting R2 as 50 kilo ohm, which is maximum. So R2 is maximum, and therefore your I2 is minimum. So that's why we had connected, high value of resistor over here, that is 50 kilo ohm. Okay, so that there would be very less amount of current flowing through this particular path. On contrary, there would be high amount of current flowing through this particular part. And if IB is high, then obviously the output current would be maximum. That means what, the voltage drop across the base emitter voltage would be greater than 0.7 volts. So therefore our BJT acts as a closed switch, and then what, and then this BJT will glow. See, it will glow. That means what, it is operating as a closed switch, and this particular LED is going to be on. Okay, it will switch on. Okay, and then it will give certain amount of light, or it will emit certain amount of light. That means what, this LED is going to be on. And let me just write over here. So let me check what all points I had written in the previous cases. Just a second. Okay, so when torch is on, just a second, when torch is switch on, BJT acts as a closed switch, BJT acts as a closed switch. So therefore LED is on. LED is on. Just a second, let me check what I had written over here. Yeah, LED will be on, or LED is switch on. LED will get on. Okay, I hope you are getting my point. So now talking about the output characteristic, so let me just draw the output characteristic quickly. So this would be the output characteristic. So this is VCE and this is IC. This is VCE and this is IC. Okay, and let me just draw one load line over here. So this is how a load line can be drawn between the two maximum points, that is IC max and VCE max. Okay, let me just erase this particular thing. Yeah, and your Q point would be, somewhere over here. So this would be your Q point. Okay, and then just a second, this particular output characteristic can be drawn something like this. Okay, something like this. I am drawing with my rough hand. So this is your Q point. That means what, your BJT acts as a closed switch, and as you can see over here, the value of IC, it is maximum. On contrary, in the previous case, the value of IC, it was minimum or almost equivalent to 0. As you can see, it is almost equivalent to 0. Whereas the value of VC, that means this particular voltage, collector to emitter voltage, it was high. On contrary, over here, the collector emitter voltage, it is negligible, or it is very much less. As you can see, it is very much less. Okay, so I hope you understood this particular circuit and obviously the working of this particular circuit. Now try to relate the working of this particular circuit as if you are operating your smartphone in presence of sunlight. So let's suppose this torch, and try to relate this particular torch as the sunlight and this particular circuit as a smartphone. Okay, so when, let's suppose if you are operating your smartphone in presence of sunlight, so obviously the sunlight is going to be incident on the sensor which is present on your smartphone. Okay, and obviously just by sensing it, the resistance of that particular sensor is going to decrease, and if the resistance decreases, So therefore high amount of input current is going to flow from this particular transistor. That means what? The output current also increases, and if the output current increases, your LED would be on. That means what? In case of smartphone, the brightness of the smartphone is going to increase. Try to understand that particular concept in this way. Okay, so I hope you understood this particular concept. And talking about the VCC, this particular VCC, so we all know the LED, that means this light emitting diode, can bear the maximum voltage up till 5 volts. So let me just write over here. Again, this is a pure technical concept. So LED can bear voltages between 1.8 volts to 5 volts, right? 1.8 to 5 volts. Okay, and since we had connected 500 ohms of resistor over here, so what we can do over here, we can connect, or we can put the value of VCC as 5 volts. Okay, if you want, you can also put the value of VCC as 6 volt, but in that particular scenario you have to increase this particular resistor, that is RC, from 500 ohms to maybe 600 ohms. If you want, you can also increase the value of VCC to 10 volts, but in that scenario you have to connect roughly around 1 kilo ohm of resistor over here. Okay, so I hope you are getting my point. Depending upon this particular LED, you are taking the DC supply or the VCC. Okay, why? Because I think the 1.8 volts, this amount of voltage drop is required for the red LED. On contrary, if you are using blue LED, so the voltage drop is somewhere around 2.5 volts or something like that. But in general, each and every LED, maybe red LED, green LED, blue LED, each and every LED, they can bear the voltage, maximum voltage up to 5 volts. If you are exceeding the voltage across the LED greater than 5 volts, maybe 7-8 volts, so the LED is going to burn. Okay, so that's why we are taking the value of VCC as 5 volts. Okay, and now I hope that you understood the working of this particular circuit. You understood each and everything that we had discussed from the starting in depth. Okay, so we'll quickly revise this particular thing. So this is your automatic brightness controller, this is your sensor, this is your block diagram. Obviously this is your sensor, and this particular sensor, it is converting light energy into electrical energy, and then it is fetched to this particular BJT, and we are operating this BJT as a switch, and then the output is given with the help of the LED. Okay, and then we had seen the LDR sensor. So basically LDR, the full form of LDR is light dependent resistor. Okay, sorry. So what we concluded with these two particular cases is this. That means what? When light is not incident on this particular LDR sensor, so the resistance of the LDR sensor is high. It is in few mega ohms. It is in mega ohms, not few. It is in mega ohms, which is a very high value. Okay, and since the value of resistor is high, so therefore the value of current is almost negligible. On contrary, if you are allowing certain light to fall on this particular LDR sensor, or certain ray of light is incident on the LDR sensor, so the value of this resistance drop to certain ohms or drop to few ohms, right? So if the value of resistance is decreasing, so the value of current is going to increase with the help of Ohm's law. We saw that. Okay, and thus the LDR will act as if it is short circuited, right? So as you can see with the help of this particular graph, as you can see, as the intensity of the light increases, as the intensity of the light falling on the LDR increases, the resistance decreases exponentially. Okay, we will see this particular concept of LDR sensor in great depth when we are dealing with the sensors part. Okay, so this is what we had concluded over here. Now what we saw over here was the block diagram, I mean the representation of the block diagram. So this is your sensor, this is your controlling system, this particular BJT, and this LED acts as the output. Okay, and then I told you that I had connected 500 ohms of resistor, so that there won't be any maximum current flowing through this particular LED. Okay, and there would be some voltage drop across this particular 500 ohms of resistor, so to assure that this LED won't get burned. Okay, and this is the torch, okay, which acts as an external light source. Moving further, yeah, so when torch is off, the current I1 is less, or it is negligible, or it is 0, right? And since your I1 is 0, so therefore your IB is also 0, and if IB is 0, so therefore the base emitter voltage, it is less than 0.7 volts, so this particular BJT acts as an open switch, and therefore the LED remains off. Okay, That means your BJT is operating in the cutoff region. Okay, just a second over here. Access a clock switch, and just a second. Switch, and it operates in the operates in saturation mode over here. Okay, and then moving to the second case, what we saw, as soon as we are switching on this particular torch. Okay, so few light rays, they are getting incident on this particular LDR sensor, and as we had seen in the previous case as well, that means this one. Oh sorry, yeah, this one. As soon as the sunlight is getting incident on this particular LDR sensor, the current would be maximum. On contrary, the resistance of the LDR sensor is going to decrease, right? Great. So as soon as this particular light which is coming from the torch, it is incident on the LDR sensor, the resistance of the LDR sensor is going to decrease, and therefore maximum amount of current is going to flow from this particular branch, and thus when it comes at this particular point, IB, that means what, the current flowing from the base region or the base terminal would be maximum. Why? Because we had connected a high amount of resistor or the high value of resistor over here, which ensures that very minimum amount of current flows through this particular resistor. That means what, I2 is very much less than IB. Okay, so for that very reason, we had connected a high value of resistor. And why we want that I2 should be very much less than IB? So that our BJT should be operated in the saturation mode. So as you can see, LDR acts as a closed switch. Your IB is maximum, and since your input current is maximum, so your output current is also maximum. That means what, your BJT acts as a closed switch and it operates in the saturation mode in general. So what, sorry, extreme sorry. So what is going to happen? Your LED is going to be on. Why? Because as you can see, BJT is short circuited, so the current will follow this particular part. I mean the IC is going to follow this particular part. Okay, on contrary, over here, since it was open circuited, so IC was reaching up till this particular point, but since the circuit or the BJT was acting as an open circuit, so it was not able to go towards this particular part or towards the ground region or towards the ground terminal. Okay, so that's why it is operating in the saturation mode. And now I hope that you understood this particular concept of automatic brightness controller in depth. So now what we are going to do, we are going to simulate the same circuit which we had seen theoretically in the Proteus software. Okay, as you can see, this LDR is present with torch, and the one terminal of the LDR, it is connected to the base terminal of the transistor, the other is connected to the VCC, right? And the base this particular resistor, it is 50 kilo ohms of resistor which is connected to the base and the emitter terminal of the transistor, and this is the resistance resistor RC or the collector resistor, which is 500 ohms. And over here I had considered the blue LED. Okay, so before simulating this particular circuit, we'll come over here the component section, and I know that you might face little difficulty finding the component. So if you want to find LED, you should type LED. Okay, but you should not select this one, generic LED. Okay, light emitting diode. Rather you should move down and you will be able to see set of LEDs. So you have to select any of them. This is blue, green, red and yellow. Okay, you have to select any one out of this particular 4 LEDs. Okay, I'm going with blue. You can go with green, you can take red and yellow as well, it's up to you. Okay, so I'm I'll just move to the next component, that is LDR. Okay, so for LDR you should just type LDR, and then you will get two set of LDR, that is the generic model and the ORP12. So you should not select this generic model, rather you should select this ORP model, that means this one which is available with torch. Okay, so you have to select this one, and rest of the things I hope that you know how to find this particular things, that is batteries and BC547, that is our transistor, and then this resistor. Okay, because I had shown you this particular thing, how to find this particular thing in the component section. Okay, so now what we will do, we'll run this particular circuit. So as you can see, this torch is off. Okay, this torch is off, and therefore this LED is also off. That means what, this LDR provides high resistance, right? So now what I'm going to do, I'm going to switch on this particular torch. So as you can see, as this particular torch is getting switched on, so it is emitting certain set of light over here. That means what, this light is incident on the LDR. See over here, first this torch was off, it was in off condition, but as soon as I switch on this torch, this LED, the resistance of the LED dropped by certain amount, right? But still the LED is off, right? The resistance of the LDR dropped by certain amount, but still the LED is off. Why? Because this particular torch, it is far away from this particular LDR, right? So now what I'm going to do, I'm going to decrease the distance between this particular torch and the LDR. So let me just move this particular torch to the right side. So alright, so as you can see, as I moved this, or as I shifted this particular torch to the right side, okay, this, the value of the LDR or the resistance of this particular LDR dropped by certain amount, and due to this, what is going to happen, the LED is able to on, or the LED is switching on. As you can see, it is switching on. Similarly, if I am moving this particular torch very much closer to LDR, the intensity of the LED increases. Okay, one more time, see over here, if I'm taking this particular LDR, I'm taking this particular torch very much closer to LDR, the intensity increases more by certain amount. Okay, the increases again the intensity of the LED again, it increases by certain amount. Again, if I'm going to reduce this particular distance between the torch and LDR, see, the intensity again increases, the intensity of the LED again increases. So you can compare this concept with the brightness of the mobile. That means if you are keeping your smartphone in the auto brightness mode, so at that time you might have experienced that whenever you are operating your smartphone in presence of sunlight, you are getting this condition. That means the brightness of the smartphone, it is quite high. On contrary, if you are operating your smartphone in presence of in your home conditions, okay, or in certain darker room where the external light source is not present, so you may encounter this particular condition, indicating that your smartphone or the brightness of your smartphone, it is decreasing. So now that we had understood the concept of the brightness controller circuit theoretically, and we had also simulated this particular circuit in the Proteus software, so now we will see the real life application of this particular concept. So as you can see, this is the smartphone, this is one of my smartphone, and as you can see, I had kept this particular smartphone in the auto brightness mode. Okay, and you can see that nothing is visible to you all guys, because I had intentionally switch off my room light. So that means what, the external light source, it is negligible. Okay, and since the external light source is negligible, so that's why this particular brightness level which you are seeing over here, it is almost zero or almost negligible. Okay, so now what I'm going to do, I'm going to switch on my room's light. Okay, so that means what, as the intensity of the external light source, it is increasing, so obviously there would be some sensor present over here on the surface of this particular smartphone, which will detect that particular light source, okay, external light source, and depending on that, it will increase this brightness of the smartphone. Okay, so let me just increase this particular let me just switch on my room light, and then we'll see the brightness of the smartphone. Alright, so as you can see over here, the brightness of the smartphone, it is increasing. Okay, so that means what, there might be some sensor connected over here on the surface of this particular smartphone. Okay, so now if you could remember, I hope that you might have experienced this particular thing, like if let's suppose if you are talking to your friend or maybe to your parents, so you are touching this particular part to your ears, right? I hope you might have experienced this particular thing, like when you are touching this particular part to your ears when you are on your call, or maybe when you are talking with someone. Okay, so you might have seen that this particular brightness level, it is getting shifted to this particular side. That means what, your brightness level is decreasing, right? So that means what, there might be a strong possibility that the sensor might be present somewhere over here. So now what I'm going to do, I'm going to put my thumb over here, just a second, yeah, and then we'll check the brightness level of this particular smartphone. Alright, so as you can see, the brightness level is decaying, or it is decreasing at a very slower rate, right? And still my thumb is over here, as you can see. That means what, this thumb is not allowing the light to penetrate or to reach up to that particular sensor. There might be any sensor present over here, not necessary that there would be only LDR sensor present over here. There might be any optical sensor that might be present over here, right? In our case, we had seen, like during simulation, we had seen the LDR sensor, right? But over here, there might be any optical sensor. And now what I'm going to do, I'm going to remove this thumb, and then we will check the intensity level. So as you can see, the brightness level has increased. So that means what, there is strong possibility, or there is 100% surety that the sensor might be present somewhere over here. Okay, so now I hope that you understood the brightness controller concept in depth. Okay, so if you are loving such kind of explanation, it's my request to you all guys, please do like, share and subscribe my channel. Thank you.